Hello everyone. Today we will be discussing about a topic queues. I am Dr. Jyoti Pillai, Billai Institute of Technology, CSVTU. Nowadays, several virtual messaging applications serve the obligations of keeping in touch with friends and family. These applications maintain the hierarchy of text messages irrespective of whether the person is offline or online. But the question here is, how are these messaging applications maintaining the queue of text messages, order of text messages? The answer to this question lies in the queue of data structures. All messaging applications maintain a queue for each user containing messages to be delivered to the user. When user connects to the network, messages in the queue get delivered and later empty queue is deleted. This example clearly illustrates the importance of queues. Queue is a dynamic, linear, non-primitive type of data structure, which is very important in our day-to-day applications. A queue is an ordered list which enables insert operations to be performed at one end, which is called as rear end, and delete operations to be performed at another end called the front end. Queue is referred to as first in first out list, that is FIFO, or last in last out list, LILO, that is the item which will be inserted into the queue first will be the first one to be deleted. That is, the data element which has been entered into the queue at the last will be served last. For example, people waiting in the line for the rail ticket will be forming a queue. The one which is at the beginning of the list will be served first. Main queue operations are Enqueue and Dequeue. Enqueue is the act of adding in a new element to the queue, Dequeue act of deleting an element from the queue. Enqueue is performed at the rear end of the queue and Dequeue is performed at the front end of the queue. Let us discuss about the enqueue operation. Enqueue is the process of inserting an element in the queue. Enqueue will be inserting at the rear or tail of the queue. New element which is inserted will be entering at the rear of the queue and is called as inserting at the rear end of the queue. Enqueuing an element in a queue which is already full will be resulting in an error that is called as an overflow condition. For example, we are having a string hello and the string has been given total space of 6 characters. First 5 characters of hello has been inserted at the first 5 positions. One by one the element will be inserted. Now, the front is pointing to 0 and rear is pointing to 4. One space is left 5. When a new element G has to be inserted, we will check the rear position to see whether any space is left in the queue. So, rear is pointing to 4 which is free. So, new element will be inserted at the rear end. When we consider the steps for inserting an element into the queue, that is for performing the enqueue operation, first of all check whether the queue is full or not. If queue is full, then an overflow condition will arise. Rear will be checked with max minus 1, where max is the maximum size allocated to the queue. If rear will be equal to maximum minus 1, then it will be resulting in an overflow condition. If the queue is not full, then increment the rear to 1 by 1, so that the rear will be pointing to the next empty space. Now, add new element to the rear position, return success. Here we can see with an example that first the queue is empty, 7 will be added at the rear position. At the initial stage, when queue is empty, both front and rear pointers will be pointing to the same position 0, or you can say if it is minus 1. Then the first element will be inputted, rear will be incremented by 1, that is now rear will be pointing to 0, element will be added at the rear position, 7 will be inserted. Now, when the next element will be added, rear has to be incremented first, then 2 will be added to the new position of rear. Now, when third element has to be inserted, again rear will be incremented by 1 and the new element will be inserted at the new rear position where rear pointer is pointing to. The next main operation which can be performed with queue is dequeue. Dequeue is the process when an element is removed from the queue. Dequeue is performed whenever a delete operation is to be performed from the queue. Dequeue deletes an element from the front end of the queue. Dequeue operation is similar to pop operation of the stack. Dequeuing from an empty queue is called as an underflow condition, that is whenever a queue is empty and if the user is trying to delete an element from the empty queue, an error will occur and that error condition is called as the underflow condition. So, here again we will be taking an example, hello is there, front is positioning to 0th position where H is present, that is first position, then O is the element present at the 5th position where rear is being pointed, that is at when rear is equal to 4, that is the 5th position, O is there. Now, when an element is to be removed, we will perform the dequeue operation, and when dequeue operation is performed on this particular string, then H will be removed first and front will be incremented by 1. Steps for dequeue operation to be performed on the queue. When dequeue is to be performed, step 1 is that first check whether queue is empty, because as I told you, if queue is empty, that will produce an underflow condition, an underflow error will occur and the process has to be terminated. Front is equal to -1 or front is greater than rear. In the case of the queue, the condition is underflow. If queue is not empty, access the data where the front is pointing and then increment the front pointer to point to the next available data element, return success. Now, we have got a queue where 2 elements are present, 2 and -9. Before performing the dequeue operation, 3 elements were there, 7, 2 and -9, and when dequeue operation is performed, 7 will be deleted first. The next dequeue operation will delete the element from the front end, that is 2 will be deleted, front will be incremented by 1. Now, when dequeue is performed, front is positioning to the space where -9 is present. So, when third dequeue operation is performed, then -9 will be deleted and front will be assigned or reset to -1. Performance of the different operations on the queue can be judged by the time complexity parameters. Let n be the number of elements present in the queue. The complexities of the queue operations are time complexity of Enqueue, that is insertion operation, will be omega 1, time complexity of Dequeue will be omega 1, time complexity of queue size to be found out will be again omega 1, O1, time complexity of is empty operation is O1, time complexity of is full operation performed on the queue will also be O1. Other than the main operations which are performed on the queue, there are some auxiliary queue operations also. Auxiliary queue operations are is full, is empty and front. Is full to check whether the queue is full or not. Is empty is the function to check whether the queue has any element or not, or whether the queue is empty. Front is similar to the top operation of the stack, that is it will be returning the front element of the queue, but will not delete it. Is full is to check whether the queue is full or not. Like first of all, it will check whether rear is equal to the maximum size. If it is equal to maximum size, then is full will return true value, else it will return false value. Is empty is the function to check whether the queue is empty or not. This function will check whether front is less than minimum size or front is greater than rear. In that case, it will return true, else it will return false. Peek operation is to see the data at the front of the queue without removing it. Begin that procedure peek, this procedure will be returning the front value of the queue. Whichever value is present at the front position value, that can be accessed and that will be returned and can be used for further procedure. There are different applications of the queue. Queue procedure is used in printers to maintain the order of pages while printing. Second, it can be used for interrupt handling in the computers. The interrupts are operated in the same order as they arrive, that is, interrupt which comes first will be dealt first. It can be used in switches and rotors. Both switch and rotor interfaces maintain ingress, that is inbound, and egress, that is outbound queues to store packets. Another application of queue may be in the process scheduling of operating systems. To implement round robin scheduling algorithms in multiprogramming, queues are used. Asynchronous data file transfer, pipes, sockets use the concept of queues for processing various user requests. Customer service systems also use the queue concept. Simulation of real world queues such as call center phone systems, lines at a ticket counter or other first come first served scenario requires a queue concept. But in linear queue there are various limitations. In a linear queue, once the queue is completely full, it is not possible to insert more elements. Deletions and insertions can only be performed at front end and rear end respectively. Even if we dequeue the linear queue to remove some elements, until the queue is not set, the new elements cannot be inserted. That is, for new elements to be inserted, queue has to be reset completely. When we dequeue any element to remove it from the queue, we are actually moving the front of the queue forward. New elements cannot be inserted because rear pointer is still at the end of the queue. Even if there are some new spaces there in the queue, but rear is pointing to the maximum size of the queue. So, element cannot be inserted in the case of the linear queues. Circular queue tries to overcome the problems of the linear queue. Circular queue is a type of queue which will be giving the solution to the problem existing in the linear queue. In linear queue, element is inserted that has to be inserted only at the rear end. When an element has to be deleted, it can be deleted only from the front end. In circular queue, when any element is deleted, memory is utilized by using that particular free position from where the element has been deleted. In circular queue, the first index comes right after the last index. Circular queue is also a linear data structure which follows the principle of FIFO, that is first in first out. Whichever element came first will be serviced first, but instead of ending the queue at the last position, it again starts from the first position after the last element, hence making the queue behave like a circular data structure. In circular queue, once queue is full, the first element of the queue becomes the rear element, if and only if the front has moved forward. Otherwise, it will again be a queue overflow condition or queue overflow state. It is called as ring buffer. When the circular queue is empty, both head and tail will be positioning to the same position. Let us see the difference between linear queue and circular queue. A linear queue data structure is a type of linear data structure that serves the data in a sequential form. The elements are serviced in a sequential form one after the another. In the case of circular queue, it serves the last item in such a way that if space is there, last item can become the first item of the circular queue. In linear queue, insertion is possible only at one end and deletion is possible from another end. that is insertion is possible at the rear end and deletion is possible from the front end. But in the case of circular queue, insertion and deletion can be performed from any position, that is any element can be deleted from any position. Linear queue requires more memory, circular queue requires less memory. Linear queue, because of its deficiency, its limitation, it is less efficient as compared to circular queue. Circular queue is more efficient than the linear queue. The various operations which can be performed on circular queue, first is enqueue operation. Get the first item from the queue using the front pointer, get the last item from the queue using the rear pointer. Now, when enqueue operation has to be performed, that is a new item has to be inserted. To insert new element into the circular queue at the rear position, first check whether the queue is full, that is rear equal to size minus 1 and front equal to 0, or rear is equal to front minus 1. If the queue is full, then display that queue is full, overflow condition arised. Else, if rear is equal to size minus 1 and front is not equal to 0, then set rear is equal to 0 and insert the new element. The second operation which can be performed on circular queue is dequeue. When dequeue is performed, a new element or an element from the front position of the circular queue will be deleted. Whatever element is present at the circular queue, that will be deleted when dequeue operation is performed. But before performing dequeue operation, first check whether the queue is empty, that is check whether front equal to minus 1. If queue is empty, then display queue is empty, underflow condition arises and then go to the termination condition. Else, if queue is not empty, then front equal to rear and front equal to rear equal to minus 1, then else if front equal to size minus 1, then set front equal to 0 and return the element. There are 3 scenarios whenever an insertion operation has to be performed. If rear plus 1 is equal to front, that is rear is positioned to the maximum size, then queue is full, overflow condition arises. If rear is not equal to maximum size minus 1, that is it is not at the end of the queue, then rear will be incremented to maximum size and the new value can be inserted at the rear end. If front is equal to 0 and front is equal to maximum size minus 1, then queue is not full, set rear value to 0 and insert new element. The next operation which can be performed on the queue is dequeue. To delete an element from circular queue, 3 conditions are there. If front is equal to minus 1, indicates no elements can be inserted into the queue and underflow condition is there. No elements are there in the queue and an underflow condition arises. If only one element is there in the queue, that is rear is equal to front, then set rear equal to front equal to minus 1 and queue is deleted completely. If front is equal to max minus 1, then value is deleted from the front end and front is set to 0. Otherwise, front is incremented by 1 and then delete the element at the front end. Now, to perform the display operation means traversing through each and every element of the queue and return that value present in a particular position. So, initially front has to be checked. If front is equal to minus 1 and rear is equal to minus 1, then print that the queue is empty. Else, if the pointer we are taking, that pointer has to be initialized to rear first and then rear value will be printed out. I will be incremented, that is the loop will be continued till the value has reached the rear end. One by one the elements will be traversed and will be displayed. Now, we will be considering the second type of the queue, which is called as dequeue, that is double ended queue or Deque, short form of dequeue, double ended queue. Dequeue is an ordered collection of items similar to queue. Dequeue has two ends, front and rear. What makes a dequeue different is the unrestrictive nature of adding and removing items. The difference between dequeue and linear queue is that any items can be added or removed from both the ends. New items can be added at either the front or the rear end. Likewise, existing items can be removed from either the front end or the rear end. Dequeue allows element to be added or removed from both the ends. This hybrid data structure provides all the capabilities of stacks and queues in single data structure. That is, elements can be inserted or deleted from both the ends in the case of double ended queue. But again there are two types of dequeues. The first one is input restricted dequeue. Elements that can be inserted only at one end, elements can be removed from both the ends. Like the name, input restricted dequeue, element can be inputted only from one end, but elements can be removed from both the ends. Second type of dequeue is output restricted dequeue. Like the name, output restricted dequeue removes the element only from one end, but elements can be inserted from both the ends. That is, in output restricted dequeue, elements can be removed only from one end, but elements can be inserted from both the ends. Dequeue can be implemented both as a stack and as a queue. When implemented as a stack, insertion and deletion is made at the same site, like we perform in the stack. Insertion and deletion will be taking at the top of the stack, in the case when dequeue is implemented as a stack. But when dequeue is implemented as a queue, then insertion can be done at one end and removal of item can be done from the other end. Dequeue implemented as a queue, insertion is done at the rear end and deletion is done at the front end. Other dequeue operations are add front item, that adds a new item to the front of the dequeue, needs item as a parameter and it will be not return anything. Add rear item will be adding a new item to the rear end of the queue, needs item as a parameter and will not return anything. Next operation which can be performed is remove front. This function removes front item from the dequeue, needs no parameter and returns the item. Remove rear removes rear item from dequeue, needs no parameter and returns the item which is present at the front end if implemented as the queue. Is empty tests whether dequeue is empty, needs no parameter and returns a boolean value to check whether the queue is empty or not. The first dequeue operation is enqueue. In a linear array implementation of dequeue, if the array is full, no more elements can be inserted. In each of the insertion operation, if the array is full, overflow message is thrown, overflow message will be displayed. Before performing insertion operation, these steps are taken. Take an array for dequeue of size n, set two pointers at the first position, set front is equal to -1 and rear is equal to 0. Now, insert at the front, check the position of the front. If front is less than 1, initialize front is equal to n minus 1, else increase front by 1. Add new item, for example, here 5 can be added at the array front, wherever front is positioned. Insert at the rear, check if the array is full. If dequeue is full, reinitialize rear equal to 0, else rear is incremented by 1. Add the new element, that is 5 here, into array rear wherever rear is positioned. The third operation which can be performed on array is to display each and every element of Dequeue. Take a variable I and initialize it to the front end, front variable or front pointer. We will be taking a loop and I is initialized to front and will be continuing the set of statements until I is equal to rear. Take out one by one value from the front and display it. Dequeue operations, the next main Dequeue operation is deletion. In a linear array, implementation of Dequeue, if the array is empty, deletion is not possible. In each of the deletion operations, if the array is empty, underflow message is displayed. Before performing deletion operations, some of the steps have to be followed. Take an array for the Dequeue of size n, set two pointers at first position and set front equal to -1 and rear is equal to 0. We have to delete an element from the front. Check if Dequeue is empty. If Dequeue is empty, that is front equal to -1, deletion cannot be performed as underflow condition has arisen. If Dequeue has only one element, front is equal to rear, set front equal to rear -1 and rear is equal to -1. Else, if front is at the end and that is front is equal to n minus 1, set go to front and set front equal to front plus 1. If you are considering to delete an item from the rear end, that is Dequeue is performed at the rear end, then check if the queue is empty. If queue is empty, that is front equal to -1, deletion cannot be performed, that is underflow condition. If Dequeue has only one element, that is front is equal to rear, front and rear both will be initialized to -1, else rear is at the front, that is rear is equal to 0, set rear equal to n minus 1, else rear equal to rear plus 1. There are various applications of Dequeue. The first application can be to check whether a string is palindrome or not. For example, Madam, Radar or Malayalam. For example, we are taking radar. Radar 1 by 1 R, A, D, A is inserted 1 by 1 into the queue, and if we delete the queue from one end, 1 by 1 R, A, D, A, R is released. If both the strings are giving the same result, that means it is a palindrome. The second application is A-Steal job scheduling algorithm. A-Steal algorithm implements task scheduling for several processors for multiprocessor scheduling process. The processor gets the first element from the Dequeue. When one processor completes execution of its own threads, it can steal a thread from another processor. The processor gets the last element from the Dequeue of another processor and executes it. Another application is to undo or redo operations in the software applications. Dequeue can be used to perform undo or redo operation in various software applications. With this, I am ending today's lecture. We have seen queues applications, types of queues, Dequeue and circular queue and their applications. Thank you very much.